Welcome to the course Business Analytics and Text Mining Modeling using Python. So, in previous lecture we were able to finish another module that was on Python Pandas package. So, in this particular course we have been able to cover the introductory part of the text mining and then the Python for the analytics which is the covering the major number of lectures in this course. Because Python is the platform which we would be using extensively for text mining. So, we were able to cover the basics for Python, the built-in capabilities, the numerical Python package and the pandas. Now, we are coming to the part where we would be talking about how we can use Python to work with data. So, we would be starting those aspects in this particular lecture. So, let us start. So, as you would expect that in this part we would be using some of the packages and libraries that we have discussed in the previous lectures. So, we would be in this first thing will load required library modules. So, first thing is NumPy as NP, Pandas as PD and certain library within Pandas series and data frame that we would be using quite often. So, let me run this. So, all these are required. Then first thing that we typically do is that loading required library modules and So, first thing is NumPy and Pandas and then certain library modules there. So, let me run this and the first thing while discussing about working with data, first thing we will talk about the CSV files. Many databases they are stored in CSV file and Excel files. So, in this starting lecture on working with data we will focus on CSV files and Excel files. So, let us start with the CSV. So, first thing, reading a CSV file into a data frame. So, data frame is the particular data structure Python object where we can actually import the CSV data. So, let us take example of this file ex1.csv. Before we go ahead and import the data stored in this particular file into a data frame in this Python environment. Let us have a look at the contents of this particular file. So, as we discussed in the Python basics lecture, we can use certain magic commands for these purposes. So, in this case we are using this percentage pycat command here. So, percentage pycat and the name of the files, in this case ex1.csv. So, if I run this, we would be able to see the contents of this particular file. As you can see in the popped up window at the bottom of this page, that first we have ABCD message. So, these are the headers. Then we have the 1 2 3 4 hello and 5 6 7 8. So, these are the values. So, small data set that we have in this file for a demonstration purpose. So, that you were able to see. Now, looking at this file you could see that the values were separated by commas. So, what the CSV related function, for example read underscore CSV, they could be used to actually import that data into a read that data that particular data into a data frame. So, next line of code you can see on the left hand side we have df and on the right hand side we have pd dot read underscore csv. So, this is the function that we would be using, and within the parentheses we are passing the file path of this CSV data set that we have. So, in this case this file is currently stored in the current working directory itself. So, I just have to specify the file name. So, that is the path itself in this case. So, if I run this we would be importing the data, we will be loading the data into a data frame. So, you can see in the output 4 that ABCD message and the 3 rows 0 1 2 and the data has been loaded into the Python environment. So, this is how data stored in a CSV file can be easily imported into a data frame object in Python environment. Now, sometimes some of the CSV files might not be carrying the header row. So, how to deal with those scenarios? So, let us take an example here again. So, reading file without header. So, we have this ex2.csv file. So, let us have a look at the contents of this file again. We will use the percentage pycat magic command here. So if I run this here, and again you can see in the pop-up window that header is gone. It is the same data that we used in the previous example minus the header row. So let me close this, and the next line of code where we are calling again this read underscore CSV function. First argument is as usual that file name like we did in the previous command, and then we are specifying a header argument here, the keyword argument header here as none because we do not have a header row here. Now default column names, in case we do not have header, they would be by default they would be integer numbers would be used. So 0 to nc minus 1, that means number of columns minus 1. So that would be used by default in case header is not present. So in this case if I run this file, and you can see the output, the column names, the column index has changed and it has become the default one 0 to nc minus 1. Let us move forward. So in such scenarios where we do not have the header row in the data set, we can also use another argument called names, which will allow us to specify the column names, column index for such an data set. So you can see here we are specifying names A, B, C, D masses. So we have we have total 5 columns as you can see in the previous output. So in this case we can specify the names for those 5 columns, and again we can use the read underscore CSV function to read the data into a data frame. So if I run this, you can see in the output 7 that the header, the column names have been changed. Now sometimes we would like to skip certain rows because they have the unwanted data. Many data sets, people who have actually developed those data set, they typically to explain the data and the variables and many other things that are part of a particular data set, they have comment section there. So for our analysis purpose, for the analytics purposes, those comments might not be required. So therefore we can skip some of those rows where the comments have been written. So let us take example of this ex4.csv. So if we look at the content of this file using the magic command, let us have a look. Let me run this, and you can see the popped up window. You can see here that few comments are there, and so we have the functionality here in the read underscore CSV function, so that we would be able to skip those rows having comments. So in this case we can use the skip rows argument here, and you can see that we have specified those particular rows which we want to skip. So if I run this, we would be having a data frame with just the data that we want, and the comments have been skipped. Now let us move forward. The next thing that we can talk about is handling missing values. So in this particular context, if we look at the default behavior here, the typically when we have missing values we will have NA or NaN in the case of Python. So this is referred as a sentinel value. So the NaN that is typically used in Python is actually a sentinel value. So sometimes we would like to change this default sentinel value NaN that is there, and for that again we have certain mechanism we can use to change that. So let us take example of ex5. Let us have a look at the contents of this file. So you can see here we have NaN, all those things here. So if we want to change something like something like foo in this particular data frame. So let me first read this data frame here. So you can see now if you really focus here, we have 2 NaNs in this data frame, and you can see in the last column with the column name masses, and the third row foo is mentioned. So this is this, if we consider this as to be a meaningless string, we can change the sentinel and consider this also a kind of NA value here. So how do we perform this kind of transformation here? So we can use we can use this particular argument NA underscore values to change this marking of sentinel values. So making meaningless values such as foo using sentinels. So we can define this sentinels as a dict object here. So you can see message column, and within message column we are passing a list of such values. So in this case foo. So we would like to change this as well to NA. So if you look at the next line, let me first define the sentinels, and the next line where we are calling read underscore CSV function for this file ex5.csv, and you can see that NA underscore values argument there, and we are passing the sentinels we just defined. And if I run this, in the output number 13 you can see that the place where we had the foo, the last column with the column name message and the last row last cell. So NaN has been written over there. So in this fashion, if there are missing values with other terms, we can change the sentinel marking, and we can convert them into NaN as well, which is the default the default term to indicate a missing value. So in this fashion we can transform our data set. Now let us talk about another aspect of analytics where we would be dealing with larger data sets. So whenever we are dealing with a larger data set and we just want to have a look at the data, the kind of variables and other things that are there, so loading a large data set will take a lot more time. So sometimes just to understand the data, the kind of data that is there, it would be better if we are able to read a sample cases from a larger data set. So how do we perform this? So let us talk about the various ways we can various approaches we can take to execute this. So in the first approach that we are going to discuss, we will configure the display setting. So we will have slightly compact display setting. What we mean by this, we would like to reduce the number of rows that are going to be displayed in our output here. So this is the attribute here that we can use, pd.options.display.max_rows. So here we are specifying the maximum number of rows that can be displayed. So that is 10, and we can define it like this or any other number. So let me run this. Now this is defined. Now we will take an example of this data set ex6, which is a slightly larger file that will see we'll have a look at the shape attribute and we'll find out how many rows and columns. So I can first thing we'll load this, we'll read this data into a data frame. So df1 read CSV, and let us have a look at the shape of this. So you can see that df1 dot shape in output 16 10,000 5. So in the first dimension we have 10,000 10,000 elements, that means 10,000 rows and 5 columns. So this is 10,000 cross 5. So it is a large data set, and we would prefer to have a look at a smaller sample of this and not load all the 10,000 observations, which would be which will take time. So because we have configured the display parameters and the maximum number of rows that we can display is 10. So if I try to print df1 here, if I run this, you can see in the output 17 how many rows have been actually printed. So you can see first few rows from the start of the data set, and last few rows from the end of the data set. You can see start in the index. You can focus on the row indices here, starting from 0 1 2 3 4, and then dot dot, and those observations have not been displayed, and the last 5 observation from the end of the data set 9995 and all those things. So you can see 10,000 rows across 5 columns, that is the kind of dimension we are talking about, and only 10 observations have been displayed in this fashion. So this is quite useful when we are dealing with larger data set. Now we can achieve the same thing following a second approach. So in this case we can use n rows argument, and we can specify the number of rows that we would like to display. So again while we are reading the data from ex6.csv into a data frame, we can specify n rows. In this case let us say 5. So if I run this code here, so you can see only 5 rows starting from 0 to 4 row indices, those have been printed here. Now there is another way to but for slightly different context that can also be adopted. So in this approach, what we typically do is we use chunk size argument where we can specify a chunk in terms of number of rows. So a number of rows which we would like to sample actually, so that we can specify using chunk size. So in this case a different object is returned, not data frame, rather a text parser object is returned. So if we call this function pd dot read underscore csv and the file name ex6.csv, which is the larger data set, and specify the chunk size, let us say 500. So we would like to sample 500 observation from the full data set, then this chunk is going to be returned as a text parser object. So if I run this, we will get this TP. If you want to have a look at this, what is this TP about? So you can see in the output 20, you can see the type of this particular Python object there. Now we have a function for this kind of object, get underscore chunk. So that will allow us to display the rows from this particular object. So we can call tp dot get underscore chunk, and if I run this, you can see we are just displaying 10 observations here, because the display settings if you remember we have already configured. So that is 10. So from this chunk of 500 we have got these 10 observations. To confirm that, you can note you can observe the row indices here starting from 0 1 2 3 4, and then we have 4 9 5 4 9 6 4 9 7 like that. So you can see that the first 500 observations from the full data set have been taken as a chunk, and from that, because we had configured the display option for up to maximum 10 number of rows, so therefore 10 rows in this particular fashion have been displayed. Let us move forward. So now till now we talked about writing till now we talked about reading data from CSV file into a data frame. Now let us talk about writing a data frame into a CSV file. So sometimes certain analysis certain output we would like to write into a CSV file, and so we can use to underscore CSV method to perform this. So if we have a data frame, let us say df, and we can call this dot to underscore CSV function. And we can pass on the new file name, that is let us say write1.csv. So whatever data is there in this data frame df, that is going to be written in this particular new file. So if I run this, and because this is now written, so we can have a look at the contents of this file. So we can use this magic command %py_cat here. If I run this, we will have a pop-up window, and you can see this new file has been created and the data as well. Now let us move forward. Now there could be other delimiters. So one is CSV, which is essentially comma separated for the comma separated kind of data. Now certain text files might have data and they might be using other delimiters, for example tab spaces. So how they can be handled here. So now we'll use standard now we'll use sys.standard output. That means in the output here itself we will like to display, and for this we will like to import the sys module here, and the same function df.to_csv, and you can see we are writing to sys.std out, which is also a file but a system file. So that is the file which is responsible for printing the output in the standard in the console. So in this case it will be printed here itself, and you can see here we are specifying a different separator. So a different separator is there, and so whatever we are going to write, we will take data from df, and we will be writing that into sys.standard out in the console output, and different separator is going to be used. So if I run this, you can see in the output instead of comma we have different separator. Now sometimes in the data we might have empty string as a sentinel. So that would typically indicate for missing values sentinels that would be difficult to detect typically if we are using a simple text format. So how do we change this? So again let us take the example of this ex5. So let me load this in a data frame df2. So here you can see that we have NANs, and if I write this df2 into console output here, we can use 2 underscore CSV function here. So if I run this, and if you look at the output that some of the NANs, for example, if you look at the second row here, you can see after 4 NAN is gone, that is replaced with the empty string. So how do we overcome this? So for that we can use another argument NA underscore rep. So it will replace the sentinel marker for NA, so we can make it null. So in the next line, if you see that we can again call this function df2 dot 2 underscore CSV, and again sys dot std out, and second argument NA underscore rep, we are replacing this sentinel marker here. If I run this, now you can see after 4 in the second row we have got null to indicate the missing value. Now let us move forward. Now we will focus on Excel files, which are also typically used to store data sets. So how do we work with Excel file in Python environment? So let us talk about reading an Excel file into a data frame, and because in an Excel file we might have multiple sheets. In CSV file we have just one sheet, but in Excel file we might have multiple sheets. So how do we read multiple sheets that could be present in a file? So for this we can use Excel file function, slightly faster way if we are reading multiple sheets from an Excel file. So using this function we will get an Excel file kind of object, and that we could use to actually import the data from that sheet into a data frame. So let me take example of an Excel file, in this case ex1.xlsx. So I am using this Excel file function. Let me run this code, and this object is created. Now let us have a look at this object. So you can see here that this is an Excel file object. Now we would be using this ef this particular object in read underscore Excel function. So read underscore Excel function can be used to read the data into a data frame. So you can take an example, you can have a look at this example pd dot read underscore Excel, then ef this Excel file object and sheet 1. So we are specifying in the second argument the sheet that we would like to read from the data set into a data frame. If we have multiple sheet, we can call this function many times and different data frames can be created. So in this fashion, if we are dealing with multiple sheets, this Excel file object can really be helpful to read data from the file and from different sheets into different data frames. So if I run this and again you can have a look at the output here, output number 33, and this is the data frame that we have got. However, sometimes we would just be having one sheet in the data set, and we would be we would just be focusing on one sheet. We might not require to import the other sheets into the Python environment. So in those cases we can directly use the read underscore Excel function, where in the first argument instead of the Excel file object we can specify the file path. So in this case ex1.xlsx directly, and the first sheet 1, and we would be able to read the data into a data frame, and again you can see. So two ways depending on the scenario we are dealing with, and we would have an easy way to import and read data into Python environment. Now let us talk about writing a data frame into an Excel file. So here again we have Excel writer function. So again this is also suitable for writing multiple sheets. Whenever we are having multiple sheet, we can use the Excel writer object, and for different sheets we would be able to write in the file. So let's call this Excel writer for this for writing this seed, write 2.xlsx, and if I run this, and you can have a look at this object, Excel writer object, and we can use this function 2_excel function to actually write the data frame into the Excel sheet. So here you can see we are calling we are using df3 data frame, which will be written into this Excel file, and EW the Excel file object, and sheet 1 where this data frame is going to be written. So if we have multiple data frames to be written, we can we can use those data frame and keep on changing the sheets and different sheets we can write using this Excel write object. So if I run this, and now we can use the save function, save method to actually save this file. So ew.save, and we'll have that file saved there in the disk. Now if we want to avoid Excel writer because we are just interested in one sheet, so we can pass the file path directly to the 2_excel function, and we can write the data frame into that file. So we can also say df3 dot 2_excel and the file name write3.xlsx. So in this case, again we would be able to write that particular file. Let's move forward. Now next thing is, so till now we talked about working with CSV files and working with Excel files, and now next thing would be working with web APIs. Nowadays there are many websites which provide public APIs to provide data fields via JSON or other other format for analytics purposes, for research purposes, and many other fair fair purposes for that particular data. So to perform, there are many packages that are available to achieve this, to work with web APIs. So one easy to use package is request package. So we'll use that to work with, to demonstrate a web API example here. So first thing, import this package, import request. So we'll be importing this. Then let's take an example of GitHub website. So here we are taking further we are taking last 30 GitHub issues for Pandas posted on GitHub. So this is the URL for all these issues here. So we will be using this particular URL, and to get first thing is to get a response object, because as you could see that we talked about Excel writer object, Excel file object. Because whenever we are required to deal with a particular file or a particular object again and again, so these kind of classes are really useful, because we can use object again and again as and when required. So in this case you can see we are calling request.get and URL. So we'll get a response object for this URL, and you can look at the type of the object here as well. Now we can use JSON method. So that is to obtain a list of, so when we apply this method, what will get in the return is that a list of a list of dicts having all the data on a GitHub issue page. So except for the comments, all the data that is going to be there, this particular method is going to return that. So let me store that in v1. So v1 is equal to resp.json, and if I run this and have a look at the v1, so as I said, v1 is a list object. So you can see a list, and then the list is starting and different columns and the associated value part. So key value pairs in the dict, and many dicts are there. So you can scroll down and see for yourself. Now next thing that we are required to do is that we can create a data frame with fields of interest. That means whichever fields are required for our analytics purposes, we can pick those fields, and there will be columns, and we can create a data frame. So we can use this pd.data frame here, and v1 is the data that we are passing in the first argument, and then we can specify in the columns argument the fields that where we are interested in. So if I run this, we will have data in df4. So if I run this, you can see in the output 48, you can see number, title, labels, state. So these are the columns, and we have got the data. As you can see, the row index. So this is a 30 cross 4 column. So if you remember, we wanted just 30 rows there. So now here other values you can see, number, the title means the pandas issues and the title that has been given by the visitor, and other labels, and the stored state, whether that particular issue is still open or closed. So those details you can see in this particular data frame. So this is how we can actually deal with the we can use web APIs to download data, which could be useful for analytics purposes. So we will stop here, and in the next lecture we will start our discussion on certain other aspects of data management, where dropping NA values or replacing them. So some of those scenarios and many other things we would be discussing in the next lecture. Thank you.